There's a bizarre object flying through our solar system right now. And here's the scary part. We have no idea what this thing really is. It came from the void between the stars, traveling through space for billions of years, possibly 7.6 billion years, twice the age of Earth. And right now, as you're watching this video on October 31st, 2025, this object is making its closest pass by the sun. But here's the problem. We can't see it anymore. It's disappeared behind the solar glare. And when it reappears in December, it might be completely different. Scientists around the world are obsessed with this interstellar visitor, and they've already published nearly 100 research papers in just 4 months. Welcome to the story of 3I/Atlas, the strangest comet humanity has ever observed. Let's start with the basics, but buckle up because even the basics are mind-blowing. 3I/Atlas was discovered on July 1st, 2025 by the Atlas system, a network of telescopes scattered around the world in Hawaii, Chile, and South Africa designed to detect asteroids that might threaten Earth. At first, astronomers thought it was just another asteroid, just another rock. But then they noticed something weird. This thing was moving way too fast, and I mean ridiculously fast. To understand just how fast, think about this. Earth orbits the sun at 30 kilometers per second. That's already pretty zippy. Mercury, the closest planet to the sun, has to move at 48 kilometers per second to avoid falling into the gravity well. But 3I/Atlas, it was clocked at 58 kilometers per second, and it was still way out beyond Jupiter at the time. That's when scientists realized this isn't from around here. This object came from interstellar space, and that's exactly where it's headed after its solar flyby. It's following what we call a hyperbolic trajectory. A fancy way of saying it's just passing through and never coming back. The 3I in its name stands for Third Interstellar Object. You probably know the first one, Oumuamua, that cigar-shaped mystery that sparked wild debates about alien technology in 2017. The second was 2I Borisov, a more normal interstellar comet that honestly felt a bit boring after Oumuamua. But 3I/Atlas, this one is weird in completely different ways. First major difference, size. Oumuamua was up to 400 meters across. Borisov was about 1 kilometer wide. But 3I/Atlas could be up to 5.6 kilometers in diameter. Now, I say could be because we can't actually measure its exact size. Why? Because it's surrounded by this massive fuzzy cloud of gas and dust called a coma, and we can't separate the light from the solid nucleus from the light reflecting off all that surrounding material. It's like trying to measure the size of a light bulb while it's wrapped in a thick blanket. The Hubble Space Telescope estimates suggest the nucleus is somewhere between 0.32 and 5.6 kilometers, with the most likely diameter being less than 1 kilometer, but honestly, that's a pretty huge range. And here's where it gets even stranger. This object might be 7.6 billion years old. That's almost twice the age of our entire solar system. Let that sink in for a second. This chunk of ice and rock was formed before our sun even existed, possibly around an ancient thick disk star in the Milky Way. Second major difference, the direction it came from. Both Oumuamua and Borisov entered our solar system from above, from the northern sky, which is the general direction our solar system is moving through space. They basically ran into us head-on, or at least from a diagonal angle. But 3I/Atlas, it's a T-bone collision. This comet came in from the side, almost perfectly aligned with the plane of the ecliptic. That's the flat disk where all the planets orbit. And by almost perfectly aligned, I mean it's only 3 degrees off. For context, Pluto's orbit is tilted 17 degrees from the ecliptic plane. Space is 3-dimensional. This object could have come from literally any direction. The fact that it hit us almost perfectly side-on is a massive coincidence. It's like throwing a frisbee into a forest and having it thread perfectly between 2 trees. But wait, it gets weirder, way weirder. When astronomers started tracking 3I/Atlas in May 2025 using NASA's TESS satellite, they noticed the object was already active, already forming its coma of gas and dust. The problem was, it was still way out there beyond Jupiter, over 5 astronomical units from the sun. Normal comets from our solar system don't start doing this until they're much closer, somewhere between 3 and 4 AU from the sun. Why? Because typical comets are made mostly of water ice, which needs a lot of heat to sublimate. That's the process where a solid turns directly into gas without becoming liquid first.
So what was making 3I/Atlas so active so early? Carbon dioxide ice, basically dry ice. If you've ever seen dry ice used for smoke effects at concerts or Halloween parties, you know it starts sublimating the instant you take it out of the deep freeze. That's exactly what 3I/Atlas was doing way out in the cold depths of space. When the James Webb Space Telescope got a good look at 3I/Atlas, it confirmed the comet is unusually rich in carbon dioxide. The ratio of CO2 to water vapor was about 8:1, basically the inverse of what we normally find in comets from our solar system. But here's the kicker. As 3I/Atlas got closer to the sun, that ratio started to flip. By late September, as it was cruising through the orbit of Mars at about 1.5 AU from the sun, the comet suddenly started releasing massive amounts of water vapor, equivalent to a fire hose running at full blast. That's actually more water than we'd expect from a normal comet at that distance. It's like the comet has layers, different types of ice at different depths, each melting at different temperatures as it approaches the sun. First the dry ice on the surface, then deeper water ice getting exposed and blasted into space. And then there's the metal situation, which is genuinely bizarre. When astronomers analyzed the coma in the summer, they detected nickel vapor, but no iron. Zero. Zilch. Nada. Now, this is weird because nickel and iron are usually found together in space. They're both formed in the cores of dying stars, then blasted out into space when those stars go supernova. They typically come as a package deal. So where did the iron go? What process separated them? Nobody knows, but it gets better, or weirder, depending on how you look at it. The fact that we were seeing any metal vapor at all was strange because the comet was still far from the sun, way out in the cold asteroid belt region. CO2 sublimates easily at low temperatures, but metal, that's a different story. The leading theory is that the massive outgassing of CO2 was dragging nickel atoms along with it, like a cosmic sandblaster, ripping metal particles off the surface and flinging them into space. But that still doesn't explain the missing iron. Plot twist. By late September, iron suddenly showed up. Astronomers finally detected iron vapor in the coma, and the ratio of nickel to iron quickly normalized to what we'd expect. So 3I/Atlas is slowly becoming more normal over time, but it's getting there in the strangest way possible. Let's talk about tails, because even the comet's tail decided to be weird. When astronomers first spotted a tail forming on 3I/Atlas back in the summer, it was pointing in the wrong direction. It was a sun-facing tail. This shouldn't happen. Comet tails are formed by solar wind, radiation streaming off the sun that blows the lightest particles of gas and dust away from the coma. Solar wind blows away from the sun, so tails should always point away from the sun. It's one of the most consistent rules in cometary behavior. But 3I/Atlas didn't care about rules. Its tail pointed toward the sun. The theory is that because the comet started forming its coma so far away, the solar wind simply wasn't strong enough yet to push all that material away. So instead, gas and dust just accumulated on the warm, sun-facing side of the object, creating this weird forward-pointing tail. Eventually, by September, 3I/Atlas developed a more conventional, short, fan-shaped tail pointing away from the sun. Crisis averted. The laws of physics were not, in fact, broken. Here's another head-scratcher. The polarization of light reflected from 3I/Atlas. Stay with me on this one because it's technical but important. When sunlight hits the dust and gas around the comet, it scatters in different directions. The direction it bounces tells us about the material it's hitting. Most objects in space show positive polarization, light bouncing off to the sides. But 3I/Atlas shows negative polarization, light bouncing straight back toward the source. Not only that, it has the most extreme negative polarization of any object ever discovered. It's off the charts. This suggests the coma is made of a mixture of icy and very dark material, possibly similar to what we see in trans-Neptunian objects way out in the frozen edges of our solar system. But again, this is coming from an object that formed around a completely different star billions of years ago.
On October 3rd, 3I Atlas made its closest approach to any planet in our solar system when it flew within 0.19 AU of Mars. This was a lucky break because we have cameras all over and around Mars. The Perseverance rover snapped a photo from the surface. Not a great picture, honestly. The rover's cameras weren't designed for this, and they had to take 30-second exposures and stack multiple images together. The result looks more like a streak than a defined object. The European Space Agency's ExoMars probe got a better view from orbit, and we could see the comet more clearly, but still not enough resolution to distinguish between the bright coma and the actual nucleus. There's supposedly an even better image from NASA's Mars Reconnaissance Orbiter, which has the most powerful telescope in the Mars system. But as of right now, that image hasn't been released. Why? Government shutdown. People at NASA aren't going to work until some political stuff gets resolved. So we're just going to have to wait on that one. Right now, today, October 31st, 3I Atlas is at perihelion, its closest point to the Sun at 1.4 AU. That's somewhere just inside the orbit of Mars. This is when the comet is at peak activity, getting absolutely blasted by solar radiation, with massive amounts of material sublimating off its surface. But we can't see any of it because our view is completely blocked by the sun's glare. We're on the wrong side, so we wait. The comet will reappear from behind the sun in early December, and on December 19th, it will make its closest approach to Earth at 1 AU. That's about 150 million kilometers away, so no danger at all. At that point, scientists will be able to study what effect the sun had on the object. There's one more close encounter coming. On March 16, 2026, 3I Atlas will fly within 0.36 AU of Jupiter. We have the Juno probe orbiting Jupiter, and it will have a chance to capture one last image before 3I Atlas disappears forever into the void between stars. And here's the thing. At that distance, the comet will be cooling down, becoming less active, but it might be fundamentally changed by its exposure to the sun. Scientists are hoping that comparing before and after observations will reveal whether some of these strange characteristics actually came from the place where it was formed, or if they're just an accumulation of weird stuff it picked up during its billions of years wandering through interstellar space. Of course, we can't talk about interstellar objects without addressing the elephant in the room. Is it aliens? Some headlines have suggested 3I Atlas could be alien technology. These claims mostly come from one Harvard astronomer, Avi Loeb, who famously argued that Oumuamua might have been an alien probe. Here's the deal. Despite the weird characteristics, a growing body of observations confirms that 3I Atlas is a natural comet. It has a fuzzy coma, it's outgassing, it's exhibiting all the behaviors we expect from a comet, just with some unusual chemistry because it formed in a different stellar neighborhood. As astronomer Brian Cox put it when addressing these claims, isn't the truth wonderful enough? And honestly, he's right. We're looking at an object that's been traveling in space for billions of years, formed around a star that existed before our sun was born, carrying chemical signatures from the ancient Milky Way. That's absolutely incredible without needing to invoke aliens. So why should you care about 3I Atlas? Because this comet is a time capsule. It's carrying pristine material from the early galaxy, possibly from a region of space called the thick disk, where things have remained relatively undisturbed for billions of years. By studying its composition, the ratio of CO2 to water, the presence of cyanide and nickel, the strange polarization, we're learning that not all solar systems are created equal. What's normal here is weird somewhere else, and vice versa. According to Dr. Michelle Bannister from the University of Canterbury, we're entering an exciting phase. As 3I Atlas warms up under the sun's light, we'll be able to study the gases it releases, providing a rare glimpse into material formed in another part of the Milky Way.
And here's something wild. Scientists have backtracked the trajectory of 3I Atlas over 10 million years and identified 93 stars it would have encountered during that time. The closest it came to any of them was 0.3 light-years. That's 63,000 astronomical units. Right now, it's 1.4 AU from our Sun. Think about that journey. Just when scientists thought they had 3I Atlas figured out, they surprised them again. In late October, as the comet approached perihelion, it underwent unexpected rapid brightening that has scientists baffled. Based on its distance to the Sun and the expected increase in solar heating, astronomers predicted the comet's brightness would increase by a factor of 1.5 between May and June. Instead, data showed the brightness increased by a factor of 5. That's more than 3 times brighter than expected. This massive surge in reflected light confirms this isn't an asteroid, but rather a highly active comet with an expanding coma. But even for a comet, this level of brightening is unusual and suggests processes we don't fully understand yet. So here's where we are. 3I Atlas is currently behind the Sun, invisible to our telescopes, undergoing its most extreme solar heating. When it emerges in December, it might look completely different. It could have fragmented like 2I Borisovec did. It could have had major outbursts. We simply don't know. What we do know is that this ancient visitor from another star system is challenging everything we thought we knew about comets. Every observation reveals something unexpected. Nearly 100 research papers in 4 months, and we're still just scratching the surface. The universe is vast and full of mysteries, and right now, one of those mysteries is making its closest pass by our Sun, carrying secrets from the ancient galaxy, giving us a glimpse into processes and materials we could never study otherwise. 3I Atlas isn't just a comet. It's a messenger from deep space and deep time, and we're lucky enough to be watching it unfold in real time. If you enjoyed diving deep into this cosmic mystery, make sure to subscribe for more space science content. What do you think will happen when 3I Atlas reappears in December? Drop your predictions in the comments below. Thanks for watching, and keep looking up.